Welcome to this explainer. So, today we're doing something really foundational. We are mapping out the exact architecture of AI Fabric. We're going to trace precisely how a simple natural language request actually moves through your application policy, hits the capability modules, and finally reaches those concrete providers. If you are out there building production-ready AI workflows with Java and Spring Boot, grasping this architecture is absolutely crucial. It's the secret to keeping total, uncompromising control over your business rules and your data. Here's our roadmap for the day. First, requirements and architecture layers. 2, core foundations and projections. 3, the orchestration pipeline. Then 4, building semantic search. 5, grounded answers and actions. And wrapping up with 6, privacy, governance, and selection. Let's just jump right in.
All right, starting with Section 1, requirements and architecture layers. It's all about starting with capability, not just throwing in a dependency.
You see, a truly solid architecture doesn't start by just downloading some massive AI runtime, crossing your fingers and hoping for the best. It starts with a highly distinct application requirement, something concrete, like updating a user account safely. AI Fabric is designed to sit right inside your application. Think of it as a secure coordination layer. It bridges your existing, proven domain assets directly to those powerful model capabilities, but without actually replacing your core services.
And that brings us to a really important concept here: strict boundaries of ownership. Your Spring Boot application absolutely must continue to own the business truth, the authenticated identity, and any side effects. So what do AI Fabric and the providers own? Simply the orchestration, the retrieval, and the inference. You're leveraging the model's intelligence, sure, but you never, ever treat its output as the ultimate authority over your domain.
Now think of these 5 layers as rigid ownership boundaries, not necessarily a step-by-step sequence. At the very top, you've got your UI or API catching the request. Right beneath that, your Spring Boot application enforces your business policy. Then AI Fabric steps in to coordinate the workflow, handing off to the provider contracts which isolate that workflow. And finally, down at the bottom, concrete systems perform the actual inference. And because these are strict boundaries, a basic retrieval request might never even touch an LLM at that bottom layer.
Moving on to Section 2, core foundations and projections. Let's look at understanding dependencies and domain modeling.
So how do we actually wire this whole thing up? Well, it's essential to understand the difference between these 3 artifacts. The BOM is there to align your module versions so nothing conflicts. Core gives you those main framework contracts. And the starter, that's your convenience dependency. It automatically pulls in core, PII, and indexing. But here's the big gotcha. Just dropping the starter into your build does not magically give you an LLM provider or RAG capabilities. It literally just activates the Spring Boot auto-configuration for the basics.
Next up, you need to model your AI-facing projection. AI Fabric doesn't need, and quite frankly doesn't want, every single field in your domain model. Using specific annotations or that authoritative YAML configuration, you explicitly declare what gets exposed. Since your application wholly owns this projection, it means highly sensitive stuff like user passwords or internal admin notes don't suddenly become visible to the model just because they happen to live in your database.
Now, each module you install brings its own Spring Boot auto-configuration to the party. But I want to give you a tip right now that will save you hours, maybe days of frustrating debugging. Framework services are only created when their conditions and their required beans are actually present. So if a capability is mysteriously missing, don't just blindly copy-paste unrelated modules into your POM file hoping to fix it. Instead, check if the required provider beans are actually available and loaded on the class path.
All right, Section 3, the orchestration pipeline. Here we are tracing intent and provider boundaries.
Let's actually trace the journey of a natural language request as it moves through this policy-shaped pipeline on your server. Based on how you've set it up, this pipeline is doing a lot: resolving policy, analyzing security, retrieving evidence, maybe executing actions, and sanitizing the final response. The absolute core takeaway here: server authority is total. A browser might ask for a certain mode, but an LLM cannot magically enable a capability that you haven't explicitly configured and allowed on the back end.
AI Fabric aggressively separates the duties of these providers. You could be using a Spring AI-backed LLM and completely seamlessly combine it with local ONNX embeddings and Lucene vectors. The LLM's job is purely to generate content and figure out intent. The embedding provider, it just turns text into numeric vectors, and the vector provider simply stores and searches them. This total separation of concerns is brilliant because it lets you swap out a single layer anytime you want without rewriting all your carefully crafted domain services.
Section 4. Building semantic search. Let's see how we achieve retrieval without an LLM.
Let's break down our first specific workflow. If you want to build a local semantic search, you literally only need 3 pieces: the starter, an ONNX embedding provider, and a Lucene vector provider. Notice what is entirely missing from that list: an LLM. This proves you can perfectly index and retrieve evidence without an LLM at all. And honestly, from an operational and debugging standpoint, if a search returns 0 evidence, that empty result is incredibly useful. Honest truth.
Section 5. Grounded answers and actions. Time to add RAG, memory, and governed operations. Okay, once your baseline retrieval is humming along perfectly, you can safely start layering on RAG, Retrieval Augmented Generation. You just take that existing semantic search foundation we just talked about, and you add the AI Fabric RAG module, plus an LLM provider. Think of RAG as the ultimate coordinator. It takes the officially approved evidence from your vector provider, walks it over, and hands it to the LLM to generate an answer. The LLM doesn't decide what data gets indexed, it just works with whatever evidence it's given. Now, I need to emphasize an honest technical constraint you absolutely have to keep in mind. Fluent model text is not proof that your retrieval actually worked. A model's highly polished, confident-sounding wording can easily trick you. You've got to test both of these layers totally independently. Prove exactly which evidence was retrieved first. Only after you do that should you check if the generated response is actually honestly reporting on it.
But what about governed actions? Things like database writes or state updates. Well, the LLM is fantastic at mapping a user's natural language to specific parameters. But, and this is a big but, a strict confirmation state is held safely on the back end using the chat session module. It sits there, securely waiting until your application handler actually says yes and executes the side effect. So the model understands what the user wants to do, but your code entirely owns the trigger.
Finally, Section 6. Privacy, governance, and selection. Enforcing boundaries and making architectural choices.
We absolutely must secure this entire flow, because true security is never just some clever system prompt trick. The PII capability steps in to handle sensitive text before it ever crosses a boundary. Access policy, that remains strictly application-owned. And when you're dealing with multiple tenants, those boundaries have to be enforced at the back end using metadata scope on the vector providers. Remember this rule of thumb. If anything is uncertain, the only safe behavior is to fail closed. Slapping a warning badge on the UI is not real security. Now, AI Fabric comes with a whole bunch of optional modules, things like web integration, behavior analysis, and relationship queries, but your choice to add them must be purely requirement-driven. Please don't add behavior analysis just because you want chat memory or pull in a massive registry module just to handle one single local action. You want to keep your architecture as lean, minimal, and intentional as possible.
To really help you keep that architecture minimal, you can use this exact checklist matrix. Every time you build, just map your specific requirement to the smallest valid set of modules. For example, if you just need semantic search, you literally only need the starter, ONNX, and Lucene. You are deliberately keeping LLM generation completely out of the mix. It is all about crystal clarity and maintaining those strict boundaries. Let's wrap things up with a final thought to chew on. A truly mature Spring Boot AI architecture clearly names the modules it absolutely needs, but it also names the ones it strictly excludes. So looking at the projects you're building today, what boundaries are you going to define? And perhaps more importantly, what are you deliberately leaving out to ensure your domain stays perfectly safe? Thanks so much for joining me on this explainer, and happy building!